Okay, this is AP Calculus Practice Exam AB3, and I'm going to work number 2 for you. And I'm just going to do one problem per video for the rest of this practice exam. Okay, so it says tourists visiting an island resort contracted a mystery illness over a 45-day period. And it's apropos for today. The health authorities recorded the rate of new cases per day, and some of the rates are listed in the table below. I went ahead and wrote that out. Day and cases per day, right? So this is kind of like the X value and the Y value. N of T would be the Y value, new cases per day. So part A is assuming the table above shows a sample of values for a continuous function N of T, use a right-hand Riemann sum with 8 subintervals to approximate 0 to 45 of N of T dt. And then we have to explain the meaning. All right, so a right-hand sum means, okay, so we're going to have 8 rectangles. All right, so we're going to go from 0 to 2, that's our first rectangle, and then the cases would be 3, and then from 2 to 6, cases are 8, from 6 to 10, okay, so from 0 to 2, okay, let's do a base here and a height here. So the base from 0 to 2 is going to be 2, and then the height is 3. All right, so the area of that rectangle, 2 times 3, is 6. And then we'll go from 2 to 6. That base from 2 to 6 is 4. The height, we use the right-hand sum, so we're using, from 2 to 6, we're using the one that's at 6. Okay, the height that is at 6, so that is 8. 8 times 4 is 32. And then from 6 to 10, the base is 4. The height at 10, so the right-hand sum would be the height at the taller one, okay, the 10 days. So that's, height is 15, all right, 4 times 15 is 60. And then from 10 to 15, so you can see this is going to take a while, the base is 5, the height at 15 is 30, so that's 150, and we have to add all this up by hand too, this is non-calculator. 15 to 25, the base is 10, the height at 25 is 100, right? So that's 1,000. From 25 to 35, okay, the base is 10, the height at 35 is 50, okay, so that's 500. 35 to 40, base is 5, height is 22, right, so that's going to be 110. And then goodness, from 40, hopefully on the real test they wouldn't give you one this long. Maybe they would only give you 3 or 4 subintervals. But 40 to 45, the base is 5 and then the height is 10. So that's 50. We have to add all that up to get the sum of that interval. So that would take you a little bit. It's 1908. Okay, so that's your answer, 1908. At least that's your estimate. Well, what does that mean? Okay, well, N of T, so 0 to 45 of N of T dt represents the total number of new cases from day 0 to day 45. So you have to write it out like that. They want an actual sentence in the explanation. So remember, when you're integrating something, you're summing something up. You're totaling something up. All right, so that is what this particular problem is about. Okay, so that is part A. I'll let you pause the video for a second if you need to. Okay, part B says that after studying the spread of the disease, the health department authorities decided they could model the number of new cases per day with R of t is equal to this really unattractive function. Find R of t, or use R of t to find the average number of cases over that 45-day period. So the average, all right, so I'm not going to write it again. You know that to find an average value, and you do get to use your calculator on this part. So I was wrong about that. You would have gotten to use your calculator on the last one to add all that up. Okay, but the average value is going to be 1 over 45 minus 0, 0 to 45. And then on your test paper, you don't have to write in that function. You can just put R of t dt. You don't have to write all that out. You do have to type it all into your calculator though, right? And when you do that, you'll get 43.1528. Okay? So, you know, you want to go out at least 3 decimal places. I went out 4 on this one. But once again, one of those average value formulas. Okay, so 43.1528 average number of new cases per day over that period. And then part C says the disease is considered eradicated when the number of new cases per day does not exceed 5. Use R of t to find on what day this will occur. Okay, so what you're going to want to do is take R of t, which is 80,000, e to the minus 0.2t over 1 plus 200 e to the minus 0.2t squared. You want to set that equal to 5. That'll give you times when the cases are 5. Okay? New cases per day. You know, how long did it take to get new case per day equal to 5? So in your calculator, you'll use solve. And the worst part about this is having to type all that in and not mess that up. But you'll get 2 times. You'll get a time of 4.71, and then you'll get another time that is 48.27. Okay, well, it wouldn't make any sense to pick 4.71 because that was very early in the process. You know, the disease isn't going to be eradicated until way later in the process, okay? So, you know, you go all the way through day 40, day 45. So, that would be the one to pick. Okay, so early in the process you got equal to 5 because there weren't many cases, and then as the disease progressed, you know, by day 48, you got back down to 5 again. All right, so that is question number 2. That was a calculator question, and we'll move on to number 3 next.